Hello everyone, this is Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. In this session, I am going to discuss about the concurrent execution concept in the transaction management. So, we already discussed in the previous session about transaction management. So, in this session, we are going to discuss about the concurrent execution and the concurrency control of the transaction management. So how we are going to control the transactions, how we are going to execute the transactions in the transaction management. So what is meant by concurrent execution actually? So in the real time, multiple users are doing multiple transactions, but all the transactions are executed at a time or executed serial by serial. So all the transactions are executed and stored in the database and particular time is called as concurrent execution. So all the database transactions are updated or committed at the same time, at a single time by the users. So that it is called as concurrent execution. So in multi-user system, multiple users can access and use the same database at one time, which is known as the concurrent execution of the database. That means multiple users are performing multiple transactions at the same time on the database. So that is nothing but a concurrent execution of the database. So it means that the same database is executed simultaneously on multi-user system by different users. So different users are staying at different places, and different places, from that different places they are doing a different transactions. So while working on the database transactions, there occurs the requirement of using the database by multiple users for performing different operations, and in that case concurrent execution of the database is performed. So multiple operations, multiple users are doing from the multiple places. It should be done in interleaved manner, and no operation should affect the other executing operations. So no operation, one transactional operation is not affect to the other executional operations, thus maintaining the consistency of the database. So by maintaining the consistency of the database, that will not affect it to other transactions. Thus, on making the concurrent execution of the transactional operations, there occur several challenging problems that need to be solved. So different types of problems will occur, different types of challenges we have to face in the transactional operations while doing the concurrent execution. So by doing that concurrent execution, so what are the problems we are facing actually? So in a database transaction, the two main operations, read and write operations. So read the transactions and write the transaction or update the transactions are the two main operations. And so there is a need to manage these two operations in the concurrent execution of the transactions, as if these options are not performed in an interleaved manner. So that means the transactions are not performed one by one and the data may become inconsistent. So by doing this concurrent execution, that means by doing the transactions are not doing the interleaved manner, so that inconsistency will occur. So the following problems occur with the concurrent execution. So some of the problems will occur. So by doing this concurrent execution, so we will see what are the different types of problems will occur by doing all the concurrent execution operations. So first one is what? Problem 1 is lost updated problems. So that is nothing but a write conflict, lost update problems. So this problem occurs when two different database transactions perform the read or write operation on the same database items in an interleaved manner. That makes the value of the items incorrect, hence making the databases to be inconsistent. So that means that read and write operations are on the same database items in an interleaved manner. the transactions should be performed in an interleaved manner. So here the thing is what, whenever the transactions happened in the previous years or previous hours, all the transactional operations are executed and may not be executed. But the read or write problem is what, the reading the transaction for every minute or reading the transaction for every hour is difficult to find out which transaction is done for the first time and which transaction is done for the second time. So that the updations are having the problems. So last updated means the updates problem. So whichever the problem, whichever the transaction is happened in the previous 1 hour before or 2 hours before, that will not affect it to display the result as of now. So that means we have to lose the updates. So consider, we'll see the example, we can execute this example. Consider the below diagram where two transactions Tx and Ty are performed on the same account A, where the balance of account is 300. So when the performing transactional 1, the first transactional operation is what, read the account of A. So the read the account of A is what, 300, and the second transaction is what, debiting the 50 rupees amount. The next transaction Y, the transaction Y is having that at the time T3, it is reading the value. Then the value of transaction Y is what, 100 rupees incremented, and the transaction is at time 6, the value of A is writing the data, that means updating the data. So after debiting 50 rupees, the update is happening here at particular time of 6. At a particular time of 6, the updated value becomes some amount. Similarly here also, actually after T2, the T3 time we have to update, but the update operation is not performed at the time, and the T6 at this T6 time the operation is updated. Now the amount is what, 250. So at the T3 time you have to display 250, but instead of displaying at the time of T3, it is displaying at the time of 6. So that is last update problem. And here also the amount 100 rupees is credited to B account, 100 rupees is credited to B account. At the time of T5, it is showing that amount is some 900 or something. But it is showing after getting this 250 update, it is going to display like some amount 900. So that means the updations are not affected instantly, or not affected immediately. The updates are not affected immediately after doing the transactions. So that is last update problem. That means write to write conflicts. Those two write operations are not performed on the time itself. So write operations are not performed itself on the time. So that conflicts will occur. So here performing a write operation, here performing write operation, but those two write operations are not yet completed, not yet processed at the time, at the same time, at the instant time or at the immediate time. So we can see here at a time T1, transaction TS reads the value of account A, that is 300 only. But at the time T2, the transaction TX deducts 50 rupees from account A, that becomes 250 only. So only deducted but not updated. Alternatively, at time T3, transaction TY reads the value of account A, that will be 300 only, because it is not updated actually. At time T4, transaction Y adds 100 rupees account A, that becomes 400 only, but not updated. So 100 rupees added but not updated. At a time T6, transaction TX writes the value of account A, that will be updated 250 only. So, at TY did not update the value yet. Similarly, at T times 7, transaction TY writes the value of account A, so it will write as done. At time T4, that will be 400. So it means the value written by TX is lost, that is 250 is lost. Hence the database becomes incorrect. Hence the data becomes incorrect and the database sets to inconsistent. Database sets to inconsistent. So that means the updates are affected. The updates are affected for the transactions at immediate point of time. After finishing the transactions only, the transaction has to be updated so that last updates problems will occur by doing this concurrent execution. And second one, dirty read problems. That is nothing but a write or read conflict. So dirty read problem occurs when one transaction updates an item of the database and somehow the transaction fails and before the data gets rolled back. The updated database item is assisted by another transaction. There comes the read-write conflict between both transactions. So consider these two transactions. So at time t1, the value is read by account A. At a time t2, the value of account 50 rupees is added. So at a t time 3, it is updated. The amount is updated. At a t time 4, it is reading with some amount. And at a time t5, the server down. At a t5, server down. So here it is going to, the transaction is going to display the amount which is 250 or 350 or which is not having the effected of updation operation. It is not going to show the after affecting update operation on the transaction. It is not going to show the affecting the transaction. That is not affected transaction. So that is one conflict. So that is nothing but dirty read problems, write or read conflict. So you can perform the write operation and you can perform the read operation, but instead of showing any of the operation, it is showing that the previous first operation. So that conflicts will occur here. So that is nothing but dirty read problems, we can call it as. So at t time t1, the transaction tx read the value of account A, that is 300. At t time t2, transaction tx adds 50 rupees account to A, that becomes 350. At time t3, sometime it writes the updated value in account to 350. It shows the message actually. At time 4, transaction y reads account A, that will be read as 350. Account is updated, account is added 50 rupees and read is 350. Time t5, it rollbacks due to server problem. So that is not actually, so and the value changes back to 300 initially. So that is nothing but, so your updated balance is 350, but the server down, because of the server down, it is rolled back again for the transaction, first transaction. So now the value it is showing 300, but the value for account A is remains 350 actually. So this will happen to read the data for the particular point of time. So that is nothing but a dirty read and therefore known as the dirty read problem actually. Dirty read problem actually. And next one, unrepeatable read problem. Unrepeatable read problem, that is nothing but a write read conflict. Unrepeatable read problem, that is nothing but a write read conflict. So it is also known as inconsistent retrievals problems. Inconsistent retrieval problem. So that occurs when in a transaction two different values are read for the same database. Two different values for the same database, it will happen. So consider this two transaction tx and ty performing the read or write operations on account A, having an available balance is 300. So here at particular time t1, it reads the value 300, and at particular time t2, the transaction ty reads the value 300. At particular time t3, the transaction reads the value with the update operation 100 rupees. With update operation 100 rupees, that is debited or credit, 100 rupees is credited into account. At particular time 4, it is updated, the value of A account is 300 to 400. 300 to 400. At particular time t5, the value is readed. The value is readed, but the reading value is not having 400. That is, reading value is only for 300. So after writing that operation, it is conflicting with the read operation. After writing the transaction, it is conflicting with the read operation. So see how it works actually. So at a time t1, the transaction tx reads the value from account A 300. At a time t2, transaction ty reads the value from account A 300 only. At a time t3, by adding 100 rupees to the available balance, it becomes 400. It becomes 400. At the time T4, transaction T5 writes the updated values as 4. After that, time T5, the transaction TX reads the available value of account A, that will be read as 400 only. It means that within the same transaction, it reads two different values from account A, that is 300 initially. After updation made by the transaction Ty, it reads 400 initially. So that means it reads two updates. It reads two updates. One is from 300 and the second one is 400. So it is an unrepeatable read and is therefore known as unrepeatable read problem. Unrepeatable read problem. So that means either you have to show the transaction result as 400, or if it is not updated, then show the result as 300. But it is showing that both 300 as well as 400. So that is nothing but unrepeatable read problem. Unrepeatable read problem. So in order to maintain consistency in the database and avoid such problems that take place in concurrent execution. So to maintain the database is to be consistency, we have to avoid such type of problems. What are the problems? One is dirty read problems, last update problems, or read write conflict problems. That is nothing but unrecoverable or undesirable recipient problems. Unrecoverable recipients problems. So unrepeatable read problems. Unrepeatable read problems. So these are all different types of problems will occur by doing this concurrent execution. So to avoid this concurrent execution, we have to use some concurrency control comes into the role. Concurrency control into the role. So the next concept is multiple granularity. So multiple granularity. So what is meant by granularity actually? So granularity represents, it is the size of the data item allowed to lock actually. So whenever the performing transactional operations, all the transactions are going to be utilize the locks. All the transactions are going to be utilize the transactions actually. Utilize the locks actually. Locks actually. But so by understanding the meaning of granularity, we have to assign some locks to the different data items. So it represents the size of the data item allowed to lock. So multiple granularity. So it can be defined as hierarchically breaking up the database into blocks which can be locked. So to apply the locks for the transactions, you have to divide the database into blocks. So to apply the locks for the transactions, you have to divide the database into blocks. And the multiple granularity protocol enhances concurrency and reduces lock overhead. So it reduces how many transactions are going to be used for the locks and how many transactions are concurrently executed. How many transactions are concurrently executed. So it protocol maintains that. The protocol maintains that. And it maintains the track of what to lock and how to lock. So the transaction, how all the transactions are going to be lock actually. But all the transactions are how to lock, how to utilize that lock and what to lock. It maintains. And it makes easy to decide either to lock a data item or unlock a data item. So it decides that each and every transaction is with the lock or how to use that lock and how to release that lock. So this type of hierarchy can be graphically represented as a tree. So this type of hierarchy, so showing that all the locks for the transactions, so applying the locks and releasing the locks represented in the tree form. So for example, consider a tree which has 4 levels of nodes. So consider a tree which has 4 levels of nodes actually. So the first level or higher level shows the entire database. So it contains 4. So first one is database level, and the second one is area level, and the third one is record level, and the fourth one is files level. So this is the four levels, higher levels of the tree. It is showing the tree structure. One is database level, second one is area level, and third one is record level, and the fourth one is files level. So here the first level or higher level shows that the entire database, shows that entire database, and the second level represents a node of type area, node of type area, and third one, the higher level database consists of exactly these areas. So higher level after the database consists of exactly these areas. The area consists of children nodes which are known as files. So the areas contains children nodes. So that children nodes are, you can say that, files. And no file can be present in more than one area. So no files can be presented in more than one area. And finally, each file contains chain nodes known as records. So each file contains chain nodes. Each file contains chain nodes, and that chain nodes are known as records. Actually, the file has exactly those records that are its child nodes. So all the records of these files are going to be having the child nodes for all the database items. So no records represent in more than one file. No records are representing in more than one file. So no records are representing in more than one file. So here, hence the level of tree starting from top levels are as follows. So the first one level is DB level, database level. Second one is area level, and third one is file level, and fourth one is record level. So these levels, you can say that multiple granularity level. So you can apply the locks and apply the locks, and release the locks, for database level, and you can apply the locks and release the locks for areas level, and apply the locks and release the locks for files level, and also apply the locks and release the locks for record level. So applying the locks and applying the locks and release the locks for all these hierarchy is called as multi-granularity. So in this example, the highest level shows that entire database, and the levels below are file, record, and fields. So there are three additional lock modes with multiple granularity. So one is intention mode lock. So one is intention shared lock, and intention exclusive lock. You can say that IS, intention shared lock. And second one is intention exclusive lock, and third one is shared and intention exclusive, and compatibility matrix with intention lock modes. So here intention shared lock, it contains explicit locking at lower level of tree, but only with the shared locks. So it contains explicit locking at lower level, but only with the shared locks. And intention exclusive, so it contains explicit locking at lower level with exclusive or shared locks. So it contains explicit locking actually, but with the shared mode is intention shared, with the shared and exclusive mode is intention exclusive mode, and the shared and intention exclusive 6 in this lock, the node is locked in shared mode, and some node is locked in exclusive mode by the same transaction. So at some particular point of time, the lock is in shared mode, and at particular point of time, the node is exclusive mode. Shared mode is exclusive mode, and the compatibility matrix with intention lock modes. So the below table describes that compatibility matrix for the lock modes. So for the intentional shared mode, intentional exclusive mode, shared mode, and shared and intentionally exclusive mode, and exclusive mode. So at that time, some of the transactions are not in the exclusive mode, some of the transactions are exclusive mode, some of the transactions are shared and exclusive mode, and some of the transactions are not excluded mode also. So these are all the additional lock modes with multiple granularity. So see here, it uses the intentional lock modes to ensure serializability. To ensure the serializability, it uses intentional lock modes. It requires that if a transaction attempts to lock a node, then that node must follow these protocols. If you want to apply a if you want to apply a intentional lock to the particular transaction, it follows these protocols. So transaction T1 should follow the lock compatibility matrix. Transaction T1 firstly locks the root of the tree. So it first locks the tree. It can lock it any mode. It can lock any mode. It can lock any mode. If it T1 currently has the parent of the node locked in either intentionally exclusive mode or intentionally shared mode, then the transaction T1 will lock a node in shared or intentionally shared mode. Intentionally shared mode. If transaction 1 currently has the parent of the node locked in either intentional exclusive mode or shared and exclusive modes, then the transaction T1 will lock a node in exclusive, shared exclusive and intentionally exclusive mode. So if T1 has not previously unlocked any node only, then the transaction T1 can lock a node. If T1 currently has none of the children, the transaction has none of the children have node locked only, then the transaction T1 will unlock a node. So these are all the transactional operations, the transactional use that locks in the different modes. So that modes are nothing but shared mode, exclusive mode, intentionally shared and exclusive mode, intentionally shared and exclusive modes. So these are all the different types of modes that were observed. So observe that in multiple granularity, the locks are required in top-down order. Locks are required in top-down order. And the locks must be released in bottom-up order. So applying the locks from top-down order and releasing the locks from bottom-up order. Bottom-up order. So if transaction T1 reads a record in a file, then the transaction T1 needs to lock the database area and file in exclusive mode. Finally, it needs to lock R mode, R and S mode. If transaction T2 modifies the record A1 in file FA, then it can do some after locking the database. That means all these operations are saying that all the locks will be required to applying from top down order and releasing the locks from bottom to up order. So this is what we understand. So the transaction T4 reads the entire database. Then the T4 needs to lock the database in shared mode. Transaction in shared mode. So this is the way we can understand that all the locks. So these are all the different types of locks having the different shared mode. So this is about in the concurrent execution locks modes. So what we discussed in this session actually. So we will see once again. So in this session we discussed about the concurrent execution. So what is meant by concurrent execution? So doing the transactions, multiple transactions at different places is called as concurrent execution. So what are the problems we will occur? What are the problems we are facing by doing this concurrent execution means we can use the read and write operation problems. So our read and write problems are, first one is the last update problems, that is nothing but a write conflicts. And the second one is what? Second one is dirty read problems, that is write read conflicts. And the third one is unrepeatable read problems. So there is nothing but an inconsistent retrievals problem. And along with this, multiple granularity. So multiple granularity is nothing but the size of data item allowed to log. So you can apply the logs for the data items. You can apply the logs for transactions. So applying logs for all the levels. All the levels are nothing but these four hierarchical levels. That is the database level, area level, file level record level. So applying the locks for all the levels in different modes. One is intentionally shared mode, one is exclusive mode, one is only shared mode, and shared and intentionally exclusive modes. So all these modes you can acquire the locks and you can release the locks. But when you are applying the locks from the database to records, you can apply the locks from top to bottom order, but apply the locks from top to bottom order, but release the locks, release the release the locks from bottom to up order, bottom to up order. So this is the way we can understand the concurrent execution concurrent execution problems and multiple granularity. So you are having all these types of modes and transactional problems. So this is all about concurrent execution. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.